Hi there, everyone, and thank you very much for the invitation to speak to you. It's a great privilege to come to Cambridge and to the legendary Nokia Bell Labs. Your history is just exemplary, as you all know. This is my new book, which is, I think, unique in that it is making a very big junction between practices in architecture and urbanism and the paradigm that is emerging, that has been emerging since the early 2000s, of what is officially known as the Global Earth Observation System of Systems. This is basically the use of remote sensing from connected up to or coming or mediated by satellites to fundamentally, the vision is to create a virtual model of the environmental systems of the whole planet. Now, there are going to be massive implications for urban research in this, and there are certain existing labs around the world that are at the cutting edge, and I have seen today that this particular unit in Cambridge is certainly one of them, along with other research units like MIT, the ETH Zurich, and MIT and ETH Zurich both have labs in Singapore that are very active, and also the Bartlett College has the Centre for Advanced Spatial Analysis, which is doing some outstanding work as well. So I have done this book to basically try to explain what has been happening in all the different fields that kind of have relevance to the urban implications of the Global Earth Observation System of Systems. It's not the first promotion of this concept that I have done. This is the invitation card to an exhibition I did in Sydney with the Customs House, City of Sydney Customs House exhibition space some years ago, and we basically introduced satellite imagery that we'd acquired mainly from Digital Globe, but also from NASA and other organisations. And this is an image of the exhibition held from memory, I think about 2008 or 10. The originator of much of what we're talking about here is Buckminster Fuller, and this is on the left his 1927 diagram, which he self-published in 28, for what he called then a 4D air, ocean, world town plan. And this is fundamentally what the Global Earth Observation System of Systems is trying to do today. On the right, top right, is the world's first Earth observation image taken from the American V2, which was originally a German technology, but in 1946 it was owned by the Americans, it was being employed by the Americans. So this was a V2 rocket that took this picture in 1946 of the Earth from space, long before the 1960s, the famous 1960s images. Down on the bottom right is the drawings by Kees Bok from his legendary book Cosmic View, The Universe in 40 Jumps. And it basically shows started with a woman in a deck chair, which he drew. Later these were filmed, and Charles Eames did the famous films. But basically it was increased and decreasing views of space, the Earth from space, and at 10 times, increments of 10 times. This is a manifesto that I wrote with sponsorship from the Group on Earth Observations in Geneva, UN Habitat, endorsements from UN Habitat, the International Society for Digital Earth, which is a global science organisation. Basically, it was a 172-page summary of a lot of the academic research that has been going on. This is online at dcitynetwork.net/manifesto, and it basically showed in 2010-2012 what the state of the scene was in the science side of things. The latest book, Data Cities, is aiming to show what the state of this science paradigm is from urban, specifically urban research and architecture and design practice. What we introduced in the D-City manifesto was this diagram of how you might imagine a global technology network to be operating. Now, only an editor would really try and make a network make a diagram like this, because, and I was editing magazines and books at that time. What I wanted to know was, how would you wrap your head around such a vast concept as creating a virtual model of the planet? So I've worked it out that this is how I think of it, that there are four major areas of activity. One is research, the other one is government operations, the other one is commercial operations, and then we all belong and we all belong in the area known as commons. If you are intelligent, if you are very active, you will be in numerous parts of this diagram. You will be doing different things that relate to different agendas in this diagram of how you would imagine the progress of a virtual model of the planet. So there are 5 research themes, and they could be reversed in order. Planetary systems modelling is obviously the big idea. The next one is very relevant to national governments and how they would organise their research. Funding through virtual nations, the concept called virtual nations and networks, which is certainly where Nokia Bell Labs is a prime achiever in this space. Then there is city information modelling, and you are also here. Then there is building information modelling, which is where the most advanced architectural scientists are operating. And then there is natural systems modelling, which is basically, the way I think, is it's about specific systems, particularly on a local and regional scale, that are natural systems. And these three arenas, natural, building and city environmental modelling, they are now being in effect condensed. I've got the wrong word there, and you know what it is. On the left is a book that was very influential on me, that came out in 2000, called Architecture Must Burn. What they really meant was traditional concepts of architecture must burn. This is Aaron Betsky and the graphic designer Eric Adegaard, who published this with Thames and Hudson, which is one of my publishers in London, basically a manifesto about what was wrong with traditional architectural thinking, particularly modernist architectural thinking. And specifically they were saying it was too static, and that architecture must literally transform itself to suddenly think of itself as dynamic and also ethereal, in other words, atmospheric. In the middle image is, of course, the blowing up of the 2 biggest modernist icons of the 20th century, the World Trade Center in New York, and that was in 2001, and in 2002, Dilys, Scofidio and Renfro, the New York architects, produced this Blur Pavilion at the Swiss National Expo. Now this was for me, this was the epitome, and the world's first epitome, of what I call Astro-Spatial architecture. It's basically an anti-icon. It is totally about clean water vapor, and it's got a lot of sensory systems inside, where people would wander in and have senses of smell, touch, and sensor-mediated reactions. None of this would be possible without the mediation of satellites. And that, I think, is the change of tune that we architectural writers are looking for. This is another Dilys, Scofidio and Renfro art installation, which is called Exit. And basically they have, you're in a 360-degree cinematic space, and it's all very, very dark. You can hardly see where you're moving and how you're bumping into other participants, but it is a phenomenal experience where they're visualizing data in one of the most advanced ways at the moment. And they have this rotating globe that is rotates and circulates around the room while various data visualizations are presented in different parts of the room. This is a fascinating example of how to show people the creative potentials of data, which most people don't get. This is another New York artist on the left, Raphael Lozano Hema, who has created an artwork called Solar Equation, and in this case he's got the irony of data about the Earth projected onto a sun, ironically appearing at night in Melbourne's Federation Square. He's presented this solar equation in a number of locations around the world. Then in your own country, Britain, the light artist Bruce Munro produced this work called Moon Harvest, which is 20 cylindrical hay bales, which at night were projected with images of the moon. So this is a kind of more cosmic approach to this new sense of, I suppose, astro-spatial science or thinking. This is another example of the digital Earth idea, and this again would not be possible without satellites. This is the library, the new library in Tianjin by the Dutch architects MVRDV, and you just simply could not produce this work of extraordinary building modelling without teams being online in using the same, collaborating in the same on the same systems in the way that we have online connections to this talk today. But basically this is the cutting edge of building information modelling, one of the 5 research themes that I've identified. To the left, we're just now moving into city information modelling, and on the left we've got the classic well-known diagram by Ebenezer Howard, done in, he did a number of diagrams between 1898 and 1903, which were pretty much the beginning of the British town and country planning movement. So fundamentally he envisaged cities as having a central activity zone, and then moving out to, in effect, what became dormitory suburbs, much maligned now, but that's what he was thinking at the time. Suburbs which would be smaller places to, in effect, spend your family time away from the smoke and the traumas of the industrial early machine industrial age. On the right is a current project in Singapore by the Singapore ETH Centre, led until recently by Gerhard Schmidt, and this is Cooling Singapore, a project where they've been inventing about 40 different tools for measuring and managing the urban heat island effect in Singapore. Down the bottom right is one of their huge media walls, which is pretty much was in fact the cutting edge of. I think these are being duplicated now, but certainly they were pretty much the first urban lab to produce wall-size screens to display urban maps at giant scale. This is a project that is called Jade Eco Park by the French architect Philippe Rahm, and Philippe has basically won the job with a number of very advanced specialist engineering companies to transform a decommissioned airport near in Taiwan, Taichung, into a new ecological park. Now, like most Asian cities, this was affected by very polluted air. And his approach was to develop, he couldn't see, it seemed to me, that he could clean the entire atmosphere of the city, but he could create clean zones, different types of clean zones in the park where people could sit in certain types of comfort. There were 3 types of zones, one for clear air, one for dry air, because obviously it gets very humid in that part of the world, and the other one for cool air, again because of the temperature. Here is how the park actually looks in reality. Basically a lot of pipes conducting, in effect, air conditioning to an outdoor park, and that is an extremely advanced approach. These are a couple of, well, on the left is a brand new concept that was submitted to the recent Responsive Cities competition run by the Institute for Advanced Architecture in Catalonia School in Barcelona. This is from Rashid Gilfanov, and he's basically proposing these as air pollution cleaning towers, and he has 3 or 4 different technologies built into those towers in principle. One of them being is to blast silica gel into the atmosphere to kind of bond and to clean and extract pollutants from the air. There are several other systems that he imagines to be built into those towers. On the right is one by the Dutch studio, Dan Roosegaard, and this is called the Smog-free tower. It was set up in a Beijing park, and here it is shown in Poland, and its technology inside is said to, and this is controversially said to, extract most of the particulate matter around that tower. It's still travelling, I think, and they're developing the technologies further. On the left here in Copenhagen is Bjarke Ingels Group, the Danish architects, who have transformed an old coal-fired waste plant into a new, well, they've rebuilt it with a completely new technology, and instead of the chimney exuding carbon smoke, it's now exuding water vapour, and they believe it is safe enough to include an outdoor sports park with quite a lot of facilities on the roof. There's a hiking ramp here, and the world's tallest climbing wall, and a cycleway around the roof of that building. On the right, in Heidelberg, is the Laboratory for Visionary Architecture's rebuilding of a waste and water tank, and on the top is again public facilities which they believe are safe to use, which have exhibition spaces and outdoor rooftop terraces, and it all gets illuminated at night with very clean looking blue LED lighting and a kind of mesh veil that gives a kind of ethereal effect. This is Dan Roosegaard's idea, done with the Dutch engineers Heigeman, for solar, basically electric cars that would be recharged by driving along priority lanes that would recharge the cars through induction processes. That's part of a smart highway. That's only one part of a smart highways project that he announced in 2013. This is a more recent project, which is a light art phenomenon, where he's projecting blue LED lighting, digital lighting, across the UN Plaza in New York to simulate the effect of people disappearing, the crowds disappearing under the water in rising sea levels. This is a book that I produced with Thames and Hudson some time ago, which basically was the world's first survey of what I call the Smart Light Cities movement, which is very much closely linked. There are a lot of artists, light artists, who are doing certain projects that involve light but also involve data, and I haven't time here to go into great detail, but I categorised 3 different types of light art, three different categories of light art, and 3 different types of light art underneath those categories, and displayed this in an exhibition, the images on the right, at Customs House in Sydney, and it also was exhibited in London, and there was a seminar that was run by the architecture faculty at TU Munich a couple of years ago about this phenomenon. So it's probably the most advanced creative subset of this science movement, and a lot is happening there. This is an extraordinary cantilevered heliostat by Jan Casali on projecting out from a major apartment building in Sydney called One Central Park. There are about 320 mirrors in this heliostat, illuminated by about 2,880 LED lights, and they basically have them all programmed to I suppose, imitate in different colourways the ripples of Sydney Harbour. This was Jan's idea, and it's called Miroir de Mer. This is Dan Roosegaard again. This is solar. This is a bike path in Nuenen near Eindhoven in the Netherlands, and basically through solar energy by day, these particles in the bitumen become luminous at night, lighting the way for cyclists after dark. On the right is Thorsten Bauer, a German light artist, using Omni-glass media glass panels that are digitally activatable, digitally programmable, to produce this amazing facade on a throbbing nightclub in Hamburg. This is the Tree of Light by Laboratory for Visionary Architecture, LAVA, at the Philips headquarters in Eindhoven. Now basically these are mirror-backed panels. I've forgotten how many thousand, but I think it's 1,500 of them. And they are, by day, the mirrors are lit by daylight coming through the skylight above this. And by night they're illuminated either by LED lighting or also by luminous ceiling tiles above them. And this is all, these panels are all suspended from a frame, a metal frame. This is the cover image of Data City's book. This is The Hive by Nottingham artist Wolfgang Buttress and a scientist called Tristan Simmons. And this is built in Kew Gardens, and many of you who've been to Britain will have seen this. But fundamentally, it's a cube made out of steel filigree with a lot of sensors and digital LEDs installed, and the sensors and there's wireless networking which links to bees buzzing in the hives nearby in Kew, and you go into the centre from a ramp that's on the other side of the pathway that you see in the image on the right. You're coming in on a elevated ramp into the centre, the spherical central space, and as you stand there you get very, very ethereal experiences and the sounds of the bees buzzing from the hives elsewhere in Kew Gardens. This was also shown at the Milan earlier than this, but this is the permanent installation. This is UN Studio, another Netherlands global architectural practice, and it's quite a simple thing, but it's fascinating nevertheless, the distortions that you can get. So what has happened is they've used building information modelling software to create an extraordinary stainless steel curved form. Then they've placed under, this is in Xintiandi in Shanghai. Then they've placed a pavement underneath the sculpture that you can walk along underneath the sculpture, and that has simple linear LED strips in the paving, but they are distorted in the sculpture above, and it all and as you move along, you're getting a very extraordinary sense of dynamics and probably discombobulation, I would imagine. And certainly there's it's being captured in data form on the onlooker's iPhone. This is Ars Electronica, which is another centre for advancement, but they're not so much doing direct work on cities, except they have an exhibition space that has quite a bit of urban mapping and urban, exactly as predicted by futurists in their artists, futuristic artists as far back as the early 20th century. This is Greg Lynn from Los Angeles and also teaches in Vienna, and he's using the Microsoft HoloLens augmented reality system with enabled by Kinect software to basically set up a prototype project where he's created a physical model of a massive car plant in Detroit, what he would do to transform that site. And in order to get a sense of scale in this particular case, he has modelled in augmented reality the Tate Modern and replicated it 12 times to get the equivalent scale of this site. This is one of several experiments that he did with this HoloLens system. Very exciting. On the left is the very first, one of the very, very first effective examples of computer-aided drafting. God, nobody thinks about computer-aided drafting anymore, but this is Ivan Sutherland, some of his first experiments where using a light pen on a screen, he would draw certain shapes and they would be converted computationally to the versions that are on the right. That was in the late 50s. On the right is some of the latest work by Patrick Tresset, who gained his French robotic artist who gained his PhD from Goldsmith's computing department, where I was associated for a recent 5-year period as a visiting research fellow. And they're doing some very exciting things. But these robots are all named Paul, and they've all been algorithmically programmed to draw portraits in completely different styles. So this is all set up like a traditional art studio where every artist has got a different approach to the same subject. This is a recent prototype by Carlo Ratti of the MIT Sensible City Lab. It's called Scribbit, and it is a wall. Well, basically the robotic part is on the wall. It's suspended from two cords and can pivot around to draw erasable drawings on smooth wall surfaces. This particular drawing, Carlo tells me, is of of a diving tower that was designed by his engineer father in Turin in the 1930s. On the left is the Russian Apis core construction robot, basically creating a reasonably crude dwelling by literally laying down powder and substance of powder and binder to create this dwelling. On the right is the American architect's shop using a KUKA construction robot to create a lattice work, quite complex lattice work, open air pavilion for the one of the recent Miami design fairs, and they're using bamboo cord, bamboo twine to construct this pavilion. Here is one of the latest ceiling-mounted construction robot systems that is happening now with the Gramazio Cola research team at ETH Zurich. This is basically an extraordinary example of timber fabrication by robots. More of this to come. This is Carlo Ratti again, Sensible City Lab, producing an idea that is still in development, I believe, for rowboats, not robots, but rowboats that can navigate, self-navigate, autonomously navigate, or could be humanly navigated to get around Amsterdam's canals. And they could be clicked together to create bridges across, temporary bridges across the canals, or they could be a sound stage for a musical performance, or they could be individually operated, and they have weatherproof screens to protect parcels and people from wave splash or or just not, obviously not rain, and they're solar powered. On the top left is NEC's NeoFace facial recognition system. I don't have to tell you the implications of these systems. And on the bottom is Intellivision's vehicle recognition systems. On the top right is 3D LiDAR scanning of a small town in Germany. That point cloud. This is being merged into building information modelling. These point clouds are having a big impact on particularly heritage restoration projects. And on the bottom right is Esri's City Engine city modelling software, which is incredibly quick to do simple but simplified but equally complicated in terms of the scale of the modelling versions of cities, procedural modelling. That was developed by Pascal Mueller at the ETH in Zurich some years ago. On the left, well, I think this is Christoph Reinhardt from MIT's Sustainable Cities Lab. He's developed an urban modelling interface, which is, in this case, in the left, I'm pretty sure it's a collaboration with Cambridge City Council on walkability analysis, several types of energy consumption, and I think some weather mapping. On the left is a very old example by my colleague Richard Simpson, who I've worked with on editing the D-City Manifesto. He was one of the most advanced computer modelers, building modelers. This is back in the days of CAD, but what he was doing, I think this is the 1970s or very early 80s, he was basically modelling how you would understand dynamically the actual shadowing effects on neighbouring properties of different developments. And it was very, very advanced for its time, and tackled in Auckland City Council area, and it produced a major change in the Building Regulation Act of that time. On the right is a very recent example of dynamic vegetation time series modelling by Thomas Gooch in Melbourne of the Office of Other Spaces. And this is modelling changes of vegetation on a month-by-month basis in the Melbourne provincial city of Bendigo. This is Barcelona modelling by 300,000 kilometres, the studio in Barcelona, and they work closely with government agencies there to do various dynamic mapping projects, and they're very, very good on their visualizations. This particular project is mapping the current uses and potential future uses of the centre of Barcelona at night. And that is the end of our presentation. Thanks very much.